All right, good morning, class. Okay. All right, let's get rolling. We are now 4.5, logarithmic properties. Okay, let's see. So, the glimpse to the future. One of the examples they like to use in talking about logs is the pH balance, okay? pH goes from 0 to 14. Water is a 7 right in the middle. So things less than a 7 are acidic, things bigger than a 7 are basic or alkaline. And it depends on the hydrogen ion content, okay? So an ion is an atom that's missing some electrons, right? So if it has orbitals where electrons are missing, the atom, well, it looks for another atom that has an excess of electrons, or it tries to steal the electrons from another atom, which bonds them together. So the more acidic, the more active it is, all right, as far as it's trying to bond. Okay, so this is log base 10. Remember, when they don't write the base, they mean log base 10. We'll see here soon that you can, let's see, I have m to the r. We're going to see that you could take exponents and put them out front. Or you could take a number out front and put it in as an exponent. All right, so if you make that negative, it's the same thing as dividing. Okay, so if you know the hydrogen ion content, you can figure out the pH. Or if you do 10 to the power of both sides, right, these undo one another. And then you can take the reciprocal of both sides and see that the hydrogen ion content is just 10 to the negative pH. So if I give you the pH, you can figure out the hydrogen ion content, or if I give you the hydrogen ion content, you can figure out the pH. And we'll get around to that later. So here's some examples of this product. Well, we're doing the product rule first. So here's another rule. I guess I should just write them down. Here's your two basic rules. Log m to the r is r log of m. That's one of them. Right? Take the exponent, put it out front. The other one is log of m times n, log of m plus log of n. So here's the two rules we're going to learn today and apply. All right, it's going to be an easy section. Okay, these things, they're obeying the rules of exponents. Let's say I have b to the x equals y. X is the exponent, right? If I take log base b of both sides, x is log base b of y. X is the exponent. Logs are exponents. They obey the rules of exponents. Here you have an exponent to an exponent, basically. If you have a to the b to the c, you multiply the exponents. That's what we're doing here. It's like an exponent to an exponent, so you multiply them. This one is following the fact that you have a like base. This is a to the b plus c. So if they're multiplied with the same base, you turn them into a sum. All right, so that's what that's about. Okay, these are useful tricks. Look at this thing. So the 1 can be written as b to the 0. Log base b of b to the 0 is 0. Or if you have log base b of b, this is the same thing as b to the first. Those undo one another, okay? You have log base b of b to the x, those undo one another, x is x. And likewise, b to the log base b undo one another, right? So you can have log base b of b to the x, or b to the log base b of x, still x, because they're inverses of one another. Notice this is in the exponent, we're not multiplying, okay? So here they say if you have log base b of m equals log base b of n, right, the same base, then m has to be equal to n. Well, you can see that easily, just do b to the power of both sides. M has to equal n. So this section we're going to prepare, you're going to learn the mechanics to set things up so you can solve equations. The next section will actually start solving equations. Okay, so we're taking it really, really, really slow. Here's the proof. All right, if you want to look into that. So using what we know, here's a product. You can bust it into a sum of all the things multiplied together. Okay. And likewise, if you have something like that, right? If multiplying is addition, then dividing is subtraction. And you can see that easily by rewriting the m over n as m times an n minus 1. All right. So you can break it into a sum, and then that minus 1 comes out. All right. And that would give you the minus, right? You could say like this. And then that comes out and turns it into a minus. So you also have the quotient rule. All right. First, let's do some quick examples here. So they just want us to expand. Well, this is all inside the log. You have three things multiplied together. You have a 30. You have an x. And we have a 3x plus 4. Those are the three things. So we can bust it up into three different logs. Here we have two things multiplied, an 8 and a k. So here's your quotient rule. Exactly what you would think it would be. All right, here's your quotient rule. Here's the proof. Let's see, what do they do here? So they do some factoring in this example. And then this can be written as log of 2x minus log of 3, because the 3 is on the bottom. Okay, oh, and the 2x being a product, you can write as log of 2 plus log of x. Let's look example. So here's your quotient rule. I'll paste that in the notes just for fun. All right, the things that are on the bottom get a minus. So this dude, expand it. All right, on the top, there's three things, a 15, an x, and an x minus 1. So we have a 15 plus the log of the x plus the log of the x minus 1. And on the bottom, we got two terms. So those are going to be negative. And then the 2 minus x. Now, remember logs, this whole thing, everything in there has to be positive, right? But you can also look at this and say, oh, well, x can't be 2, right? because that would you be dividing by 0. And here x cannot be -4/3, right? This whole thing has to be positive, right? But if we expand this into this, everything like this tells you x has to be positive. You can't take the log of a negative number. This tells us x has to be bigger than 1. This tells us x has to be what, less than 2. So we're already seeing x has to be positive, but it has to be less than 2. Okay. So in the next section, when we start solving equations, we're going to see that this might be defined for more values of x than this. So we're not going to be able to say logical equivalence. All right, because when we go from here to here, we might be adding solutions in or losing solutions. So we'll have to be careful with that. We'll see that in the next section, right? So combining all these conditions. Okay, so x has to be positive, but it has to be less than 2. The only places that this dude is defined, all right? So it's a subtlety we'll look into in the next section when we start solving. All right, so we want to expand this. One thing we could do is factor, right? Let's see, on the top, I could pull a 7x out. That would be an x plus 3. And I have down here, what is 7x, x minus 1, and x minus 2. So those could cancel out. We have a log base 3, x plus 3. These are on the bottom, so we have to subtract. Okay, so we could simplify there. All right, now here's the power rule. All right. So they tell us here that you could take the exponent and put it out front. Or you can go the other way. You can take a number out front and make it the exponent. Okay. Like this up here, we could take the 2 and pull it out. You can see x squared is x times x, and using the sum, you write it as log of x plus log of x, which gives you your 2 log of x, which is equivalent as pulling the exponent out front. So those are 2 basic tricks. All right. This section is going to be easy. We're just basically applying those 2 tricks over and over again. So this dude says I can pull that 5 out front. This one says I can pull that 2 out front. There's a couple more. So 25 is 5 squared. So I could bring the 2 out front. This is x to the minus 2. That means I can pull that minus 2 out front. All right, this is useful when you have stuff like this. Let's say 5. I'm trying to solve for x. How do I get to the x? What am I going to take the x root of both sides? Right? What the hell is that? All right. What this says is I can take log, any log I want. Let's say I take natural log of both sides. That means I could take the x and put it out front. That means x is natural log of 5 over natural log of 2. So I could solve for x. And these are buttons I can plug into the calculator. Now, I could have taken log base 2 of both sides right? Those undo one another. So these are equal, right? But I don't have a log base 2 button on my calculator, right? I have a natural log. And we're going to see later in this section, there's a change of base formula, all right? So these are equal. It's just different bases for the logs. Log base 2 versus log base E. So you might get, when you start solving for X, depending on your approach, you might be getting different looking answers. And it's simply because of a different base and log. This we could rewrite as x to the fourth. You could take that and make it an exponent. This we could take that 2, make it an exponent. So expand this guy. We have an x to the fourth. That would be bring the 4 out front. Then we're multiplying by the y. But then we're dividing by the 7. All right, this one we got log the x squared. Comes the 2 comes out front. The y cubed. And bring the 3 out front. The z to the fourth is on the bottom, so we have to subtract. And the 4 comes out front. Okay. This is square root of x is an exponent of 1/2. And bring the 1/2 out front. This is x to the 2/3, right? It's x squared to the 1/3. So we could write this as 2/3 natural log of x. Just bring the 2/3 out front. This guy, an important distinction here. These are not multiplied, they're added. So no, you cannot expand that, right? They have to be multiplied together in there. So the log of a sum, kind of screwed with that. Here's a couple that are a little more complicated. All right, we got 1, 2, 3 things on top, 1 thing on the bottom. We could write this 64. We could write that as 2 to an exponent if we wanted to, but the x cubed becomes a 3 out front, bring 3 out front, and then we have minus equals the plus, right? Turn it into a sum. So log of 64 plus 3 log of x plus log of 4x plus 1. Now the 2x minus 1 is on the bottom, so it's negative. This thing over here, notice we have the square root of this. The square root of an x squared, those undo one another. So for the first thing, this is a 1/2 as an exponent. And then the 2x plus 1. This is really x minus 3 times x plus 3, right? This is the difference of 2 squares. And since they're on the bottom, we need to subtract. This is minus natural log of x minus 3 minus natural log of x plus 3, right? They're both negative because they're on the bottom. And of course, we can go the other way with this stuff. All right, since these are all log base 3, and that's important, they have to have the same base, we can combine these into one log. The 5 is positive, the 8 here is positive, the 2 is negative, so it goes on the bottom. This is 40 divided by 2 is 20. These are all log base 10, same base, so we can combine them. The 3 is positive, the 4 is minus, 5 is positive, and then the 6 is minus. So we can simplify this. Let's see. 6 is 2 times 3, right? There's a 5 on top and an 8 on the bottom. It's the log base 10 of 5/8. All right, now these are all log base 2. So we can combine these into one big log base 2. This one's positive, it goes on top. This one's positive, it goes on top, x minus 1, and this can be written as an exponent. This one's negative, so x plus 3 goes on the bottom. X, so if you square something and cube it, let's do the 6th power. All right, x plus 3 squared, and then cubed is the 6th power. These are all the log base 10. They all have the same base, so this is, we can combine these. So this one, we have a 5 on top. This is an x, and then this can be moved out. On top is an exponent, so that's a square root. This one's on the bottom, so we have 7x minus 1. This one's positive, so it's on top, and that could be written as an exponent. Okay, so these logs are all log base 10. This one is positive, the 2 can come up as an x squared. This one's negative, so the x plus 5 is on the bottom. If this 4 becomes an exponent. This one's positive, so it's on top, but the 1 over x becomes an exponent. This one, notice everything is being multiplied by 4. I'd multiply the 4 through first. So 4 times 3 is 12. And we got 4 log of x plus 5 minus 4 log 2x plus 3. So these are all the same base, all log base 10. This one gives me an x to the 12th. This one gives me an x plus 5 to the 4th. This one's negative, so it's on the bottom. It's a 2x plus 3, again, to the 4th. What are they doing here? If we double the hydrogen ion content, what is the effect on the pH? All right, well, I'm going to call it pH prime. If I take the H plus and I replace it with 2H plus, what happens? Okay, well, let's look at it this way. Negative, this would be log of 2 plus log of H plus, which is negative log of 2 minus log of H plus. Well, this is my old pH. So my new pH is my old pH minus log base 2. So what's happening is pH decreased by log base 10 of 2. So if you double the hydrogen ions, your pH goes down. Okay, so the higher your hydrogen ions, the lower your pH. So remember, a low pH was acidic, so the more hydrogen ions, the more acidic it is. And again, a hydrogen ion is an atom that's missing electrons, so it's trying to bond with other stuff, so it's highly active, right, because of the missing electrons. So the more hydrogen ions, the lower your pH. If you double your hydrogen ions, the pH decreases by log base 10 of 2, which is approximately 0.3, right? So every time you double the hydrogen ions, your pH decreases by about 0.3. So you really have to add a lot of hydrogen ions in order to decrease your pH by a lot, you know. And what if we go the other way? All right, what if we decrease it by half? Well, if doubling it decreased the pH by 0.3, I think that if we cut the hydrogen ion in half, that'll increase our pH by 0.3. And let's look and see. We know that pH is negative log of H plus, right? So my new pH is going to be the one where I cut my hydrogen ions in half. So let's see what we get. Negative log H plus minus log of 2. Distribute this minus. Minus times a minus is a plus. And this is our old pH. And then we're adding log 2. So this is, if you cut your hydrogen ions in half, your pH goes up by 0.3. Just like doubling it decreased it by 0.3. And here's your change of base formula. It's not hard to remember. So here's their proof. All right. If you want to look into this, you can. We really just want to be able to use it in here. All right. If you're a math major, you're going to want to look into this. You'll be able to figure it out. Basically, it says, let's see, let's say I want a different base here. All right. So I'm just going to write my new base. I'm going to call it K. Well, I can't just change that. What I have to do is divide by, I'm changing to base K. So everything over here has to have the same base. I have to divide by the log of the new, with the new base of the old base. So if I have log base 2 of 3, well, I don't have a log base 2 button on my calculator. I have a natural log button, but I have to put natural log of the old base. Okay, so this you can plug into your calculator. That can't. So notice everything over here is the new base. something you can plug into your calculator. This number hadn't changed. So all I did was say, nah, I want a new base. But I can't just change the base unless I divide by the log of the old base. Okay, so it's not hard to remember. And there you go. Yeah. They'll change from base B to base N. All I had to do was divide by log base N of the old base. Let's look at some examples here. All right, so I want to switch to a natural log. Okay, but I can't just write natural log of 3. I have to divide by natural log of my old base. So here, if I want natural log, switch it to natural log, but I can't just switch that unless I divide by the natural log of the old base. Okay, so this is log base 10. If I want to switch to natural log, well, I just switch the top to natural log. Then I have to do natural log of the old base. Okay, so we want to type this into a calculator. You can use log base 10 or natural log. I would use natural log because it's 2 letters to write instead of 3. So I could do that, and I have to do natural log of the old base. If I did log base 10, I'd be like, it's log base 10 of 10 over log base 10 of the old base, right? The top here is just 1, right? You still got to plug it into a calculator, right? These are equal. Here, I can change this to natural log. So divide by natural log of the old base. Or if I did log base 10, to divide by log base 10 of the old base. Of course, this is 10 squared, right? So the log base 10 of 10 squared would be 2. So these are equal, right? So what your answer ends up looking like when we start solving equations will depend on what your favorite log is, right? I always recommend using the natural log. It's just faster to write. It's prettier, right? The only reason this is important is because we have 10 fingers. That's why we use a base 10 decimal system. If we had 12 fingers, we'd use a base 12 number system, okay? So the natural log is just prettier because it's inherent in the universe, not just human based. This is universal based. Okay? That's it for this section. Next time we will do whatever the next section is, which hopefully will be actually solving equations. All right, any questions about anything? If there's no questions, we will get out of here then. All right. I still haven't got the Desmos thing worked out. I might just give everybody full credit for it for this complex numbers one. And we will do Zoom on Wednesday. I think we did good Zooming today. The weather's horrible outside. So we'll Zoom again on Wednesday. All right, bye everybody.